So, in making high-purity carbon nanostructures at industrial volumes, you then direct those as the building blocks for a wider array of products and profit-making enterprises?
That is correct. We will use the carbon nanostructures for things like nanofilters, also automobile bodies, and we have quite a growing list of aerospace companies who need what we make because of the strength of our product.
Okay. I have looked at the presentation you made at ELA Berlin 2010 on June the 9th. Can you inform viewers who was in that audience and what sort of impact that presentation made on them?
The primary audience was German and Russian. I was invited by the Germany-Russia Business Alliance. We have been doing collaboration with the Russian Academy of Sciences for the past 30 years, so they're very familiar with us. Plus, there had been 2 magazine articles that appeared in a Russian high-tech magazine named Svertnovaya Realnost. That translates to Super New Reality. So they're very aware of us, and we had a sprinkling of executives in there from the EU, from Airbus. There was also several people there from Lockheed. So we had a very wide array of aerospace executives, people involved in the airline operations, design, manufacturing, and even the scientific research.
Is it accurate to say at this time that your company is aligned with the Germany, Ukraine, and Russian aerospace companies, and maybe even beyond that?
Yes, it is. We have, in Russia, we're working with 4 different groups. One is United Aircraft. That's the company that makes Sukhoi, the Tupolev, and also Ilyushin aircraft. They're very much working now with Airbus on several different models. We're also collaborating with Antonov, which is based near Kiev. They make the largest freight air jets in the world. And some of that is starting to reach out into other nations now as we seek collaboration partners. Like I recently spent a week and a half in Denmark, and what we were focusing on there was precision metals machining. You know, people who would be making some of these components with us or for us.
Does that include both carbon nanostructures production and the secondary products your company will make from those building blocks?
Yes, it does. The carbon composites that we're going to be working with on aerospace is used for the wings. It's also used for the entire tail section and vertical fin on airplanes. The airplane of the future, when you get past the last seat into the where they have the bulkhead and the restrooms in the back of the airplane, that is all going to be made out of carbon composites.
What sort of opportunities does your company foresee for Italy?
Well, I'm well aware that Italy already has an indigenous aerospace industry. They could certainly be collaborating with us on many of these projects. And also the sexy Italian cars, they use a lot of composites on those cars right now, but the type of composites that we are bringing to aerospace are much stronger than many types of metals. So I think over time, some of the automakers like Ferrari, Maserati, Lamborghini would be well served if they worked with us on developing stronger automobiles.
When considering what I know thus far about nanotechnology, is it accurate to say that so many nations and universities are focused on this new science because of the impact it is going to have on our economies, job creation, and future on this planet?
Yes, that's very accurate. What is happening is this is a new industrial sector that is highly driven by scientific research and technical expertise. And most of the nations on this planet, way more than the G20, have already developed very robust programs to research and develop so that they can build their own economies and create jobs for their own people. And as far as the future of the planet, we're working on technologies now where jet engines, automobiles, trucks, tractors could be powered with water. They will not be powered with petroleum. And even though that sounds kind of scary to the petroleum industry, carbon nanostructures is a petroleum-based product, but it's a much higher value product, a much higher value added.
I'm aware of the projects that you are working on in Germany. I think 7 major nanotechnology production centers. Can you tell the viewers about what those facilities will be making?
Yes, I can't disclose where this is going to be yet, but we will have a carbon nanostructures production center there that is making the nanotubes and the nanofibers. Very close to that facility will be a type of facility that's making carbon composites for aerospace and outer space applications. But we have already moved way past just the building blocks. We're putting 3 operating units there that make space propulsion. One of our scientific teams developed an extremely fast and powerful type of system for outer space. A derivative of that is being researched to be applied to a type of a new airplane that can take off at an airport, go into outer space, and return to land at an airport because it's not dependent upon oxygen for combustion. And we're also collaborating with German, Ukraine, and Russian companies in the development of jet turbines that would operate on water. And then we have another one we're putting there, and I can tell you why we're putting it there. It's a major freight hub for handling overnight packages, but we will be sending out and then bringing back used nanofilters. Instead of dumping those in landfills, we want them back so that we can recover the nanoparticles that are lodged in our nanofilters. We need the nanoparticles for other research and other types of applications.
Do you see similar types of opportunities for Italy and the diverse manufacturing base we have?
Exactly, yes. I see several possibilities of where we could put a carbon nanostructures plant in Italy, and that would provide the building blocks for the other type of products that we're describing here. We tend to put our operating units very close to our carbon nanostructures plants, but we also put it close to indigenous populations and workforces that have an expertise that we need for next generation type applications.
Many talk about the risks of nanotechnology. Can you address that for our viewers?
Yes, I love to talk about the risk of nanotechnology. The risks are actually at multiple levels. For example, aluminum as we see it and use it every day is not explosive and it's not flammable. But once you reduce it to a nanopowder, it's extremely explosive. The same applies with magnesium. It becomes not only flammable, which it is anyway, but it's also explosive. But we've learned through firsthand experience there are ways to mitigate that through process design, engineering, handling facilities, to where the risk of explosion or fires is completely eliminated. So you have to be very good at the engineering side of this as well as the research. The other part of it that we have been very focused on is toxicology. Nanoparticles are more volatile than normal materials, but not all of them are, not all of those particles in nanopowder or nanoparticle form remain in a toxicological issue. Once you lock it back into a bigger product or a bigger component, the volatility and the toxicology issues many times just disappear. But you do have mid-step procedures that you have to be very careful with.